This is lesson 2.6 on lines through 2 points. Now we've been talking about functions and graphs of relations. One of the most basic graphs that we've encountered in our math career are lines. And if you remember from your geometry class, a line is determined by 2 points. Really what it boils down to, what we need to determine to define a line is a single point for the line to go through and then some sort of slope, some sort of direction for the line to go in. In our basic Euclidean geometry, we have this postulate that given a line and a point, there's exactly one line through that point parallel to the second line. That's actually just an assumption. When we assume different things happen, but we're going to go with the easy stuff. We're going to use our normal geometry. We're going to use our normal distance and normal ideas. So between any 2 points, there's going to be exactly one line here, or between every 1 point, there's exactly one line parallel to some other given line. Now, the most common forms for the lines that we've encountered in our algebra classes before are the slope-intercept form and the point-slope form. Hopefully we have seen both of these before. I'll be a little sad if you haven't, don't tell me, but I'll be even more sad if you finish this class and don't recognize these two forms. We are going to be working primarily with the latter form, the point-slope form. Now, generally, we prefer to have our final answer. If we're asked to describe a line, we will usually give its equation in slope-intercept form. Y equals mx plus b. I don't know, it just kind of rolls off the tongue a little bit better than the point-slope form. Y minus y1 equals m times x minus x1. Now, even though we will frequently have our answer in slope-intercept form, the form in which we will normally start the problem is going to be in the point-slope form. So for each of these problems, the problems that we look at today and in the next section, what we need to focus on are two things. We need to focus on the point that the line goes through. We need to focus on the slope of the line. In the point-slope form, the point that the line goes through is x1 comma y1, and the slope of the line is m. Remember, slope is just change in y over change in x. So we will normally start with the point-slope form of the line and then solve for y to get it into slope-intercept form. Now, just one word of caution. When we have perfectly vertical or perfectly horizontal lines, this kind of all goes out the window. We're going to do something a little bit differently, different. When we have a perfectly horizontal line, when that occurs, notice that our y value is constant. Y is constant, so the equation for that line will be y equals whatever constant that is. For a perfectly vertical line, you'll notice that the x is constant. X equals a constant is going to be the equation for a vertical line. So be on the lookout when we're approaching these problems. Make sure that we aren't talking about a perfectly horizontal or a perfectly vertical line. If we are, we're going to follow slightly different rules. But if they aren't perfectly vertical or perfectly horizontal lines, we're always going to follow this exact same routine if we want to find the equation that goes through a given pair of points. So let's take a look at this example. Find the slope-intercept form of the line through -3, 4 and 2, -1. Now again, even though we want to have our final answer in slope-intercept form, we're actually going to begin with point-slope form. So remember, this is our point-slope form right here. So x minus x1. Now, we need a slope and we need a point. It actually doesn't matter which point you choose, but I would encourage you, just go ahead and make some sort of note to yourself that you don't mess things up. I'm going to call this my x1, y1 point. This is my x2, y2 point. So I know that y1 in this case is going to be 4, x1 is going to be -3. If you chose this to be x1 and y1, you'd get the same exact answer when you get to slope-intercept form, so don't worry about that. Remember, our slope, that's our change in y over our change in x. So y2 minus y1 over x2 minus x1. Again, if you switch the if you call this your second point and this your first point, it's not going to affect your answer, so don't worry about that. So we have -1 minus 4 over 2 minus -3, so plus 3. So that's going to give us -5 over 5, so -1. So our slope for this line is -1. Here's the point that I'm going to use, so we're in business. Y minus y1 we said is 4 equals m is our slope. We found our slope to be -1 times x minus x1. x1 is going to be -3, so minus -3 is plus 3. So this is my line in point-slope form. To get into slope-intercept form, all I have to do is solve for y. So I'm going to go ahead and multiply everything out on the right-hand side. So that gives me -x minus 3. Now I'm going to add 4 to both sides. It's going to leave y completely by itself. So -x stays the same. When I add 4 to -3, that becomes plus 1. And that's it. That is the slope-intercept form of my line. All I have to do to get to the slope-intercept form from the point-slope form is to just solve for y. All right. Now remember, when we have a perfectly horizontal or a perfectly vertical line, the rules change just a little bit. Now I've changed the wording of the problem here. The problems that we will see on our problem sets and on the quiz, they'll most likely say find the slope-intercept form of the line. Technically, that's not what we're going to have in this case, so don't let that throw you off when we see those instructions. Once we have a perfectly vertical or perfectly horizontal line, we don't worry about the different forms of the line. It's actually, even though it's different, it's much, much simpler. So for example A, we want to find the equation of the line through -1, 2 and -1, -3. So notice our x value is constant. So guess what the equation of this line is? X equals a constant. There we go. It's that easy. Similarly over here, notice our y value is constant. 2, 4, 5, 4. So our y value is constant. Our y value equals a constant. There you go. That's simple. So even though the rules change slightly when we have a vertical or horizontal line, it actually makes things much, much easier for us. So let's consider a simple application of finding the equation of a line given 2 points. So consider this problem. The average annual salary of a high school graduate in 1999 was $25,900. In 2007, the average salary was $30,400. If the annual salary continues to grow at this rate, what will be the average annual salary when the current 7th graders graduate in 2017? Now I feel obliged to mention, this is simplifying the problem. This is what we call linear growth. There are many things that we can model using linear growth, meaning a model is something that will give us a good ballpark idea of what's going to happen, but it's not going to exactly predict what's going to happen. But in this case, we're going to assume that we can model this using linear growth, and that can give us a good ballpark idea of what's going to happen in 2017. So what we have here are actually 2 different data points. So we actually have 2 different points that we can assume that this line is going to pass through. The first is 1999, 25,900. Now if you're sure which one is which, think of it this way. Which one is what we call the independent variable? Which one is the dependent variable? So in this case, does the year depend on the amount, or does the amount depend on the year? It kind of makes more sense to think that perhaps the amount is what depends on the year. So we're going to treat the dates, the years, as our x value, and the amount of money as the corresponding y values. So this line is going to go through 1 point, 1999, 25,900, and the second point is going to be 2007, 30,400. So 2007, 30,400. Now from this point, it essentially proceeds exactly the same way as our previous problems. We want to put this into point-slope form, so we need to find the slope, we need to find a point. Again, it doesn't matter which one we use, so let's go ahead and use this point. So I'll call this x1, this y1, this will be x2, this will be y2. So to find the slope, it's going to be the change in y, so 30,400 minus 25,900 all over 2007 minus 1999. So when we take this difference, let's see here, what's this going to be? I think this is going to be 4,500 up top. No, that's, yeah, that's right. And then down below, 2007 minus 1999, that's going to be 8 years. So that works out to be, that's not going to be a terrible decimal. But if we go ahead and cheat just a little bit, this is a word problem. We're allowed to use our calculator. So if we punch that into our calculator, we're going to get 562.5. So there's our slope. Now to find the equation of our line, we just put the pieces together. So y minus y1, so 225,900 equals 562.5. This is our slope times x minus x1, so 1999. So we have y equals, if we multiply everything out, we have 562.5 times x minus 1999 times 562.5, which we find out is this fun number. Again, we're just using our calculator here. And then we need to add 25,900 to both sides. So simplifying all that, if we trust our calculator, and we generally do, we're going to get, hold on, it's trying to lie to me. Here we go. 562.5x minus another ginormous number. Alright, so this is not a pleasant equation by any means. However, it is going to give us a good idea as to what the annual salary will be in 2017. So how do we do that? We have the equation of a line. The problem didn't ask us to find the equation of a line, so it doesn't seem like we're still anywhere close to the answer. Well, we are. We just need to find essentially the corresponding y value for this x value. Remember, our y values denoted the average annual salary, and the x values were the years. So if we just take this equation that we just found and plug in 2017 for our x value, the amount that we get back is going to be the approximate average annual salary. So, punching all this into our calculator, 562.5 times 2017 minus 109,853.7.5, we get $36,025. So there's our final answer. So our current 7th graders, if they go straight into the job market after graduating, they can expect to earn on average a little over $36,000. Again, this is a model. This is not necessarily what exactly will happen, but it's a tool that will give us a ballpark idea as to what's going on.